This instructional video details critical elements and considerations for the pull-off adhesion testing process. A portable pull-off adhesion tester measures the force required to pull a specified diameter of coating away from its substrate using hydraulic pressure. The major components of a pull-off adhesion tester are a test dolly that is adhered to the coating, a pressure source such as a hydraulic pump, a pressure indicator, and an actuator for physically separating the dolly and the coating from the substrate. The PosiTest self-aligning dolly and actuator system enables uniform distribution of the pulling force over the surface being tested. It maximizes repeatability by eliminating the possibility of shear forces, which may result in one-sided pull-offs on rough and uneven surfaces. Pull-offs are always perpendicular to the substrate. Following a pull-off test, the breaking points, demonstrated by fractured surfaces, occur along the weakest plane within the dolly adhesive coating substrate system. The two most common standards for pull-off adhesion testing are ASTM D4541 and ISO 4624. The Defelsco PosiTest pull-off adhesion tester shown throughout this video is specifically identified in Annex A5 of ASTM D4541. Every PosiTest adhesion tester pressure system is calibrated and certified to a plus or minus 1% full-scale accuracy using a NIST traceable load cell. The PosiTest ATA measures adhesion on a variety of coatings and substrates, including metal, concrete, wood, and plastic. With the included 20 mm dollies, the PosiTest ATA has a range of up to 20 megapascals, 3,000 pounds per square inch. Optional 14 or 10 mm dollies increase the range of the PosiTest ATA by 2 and 4 times respectively. An optional 50 mm kit is available for low bond strength coating applications and for testing on masonry substrates such as concrete. Having selected the pull-off tester to be used, the next step is to identify a suitable adhesive for bonding the dolly to the coating. When selecting an adhesive, it is important to consider the expected bond strength and the nature of the coating and dolly. Specifications for most coatings are typically less than 1,000 psi. Thermal spray coatings are tested higher, though new standards quote acceptance levels at 1,000 psi or less. For applications under 7 megapascals, 1,000 pounds per square inch, or when a fast-curing adhesive is required, cyanoacrylates, superglues, are commonly used. When stronger bonds are required, it is recommended that a 2-part epoxy be utilized. Several manufacturers utilize Araldite 2011 epoxy due to its versatility. Warnings: with any adhesive selection, it is important to test and ensure that the adhesive does not react to the coating, resulting in a change in its cohesion properties or bond strength. The goal of any adhesion test is to determine the pressure at which an adhesive between layers or cohesive within a layer failure occurs. To ensure pull-off tests are meaningful, preparation of the surfaces to be adhered is critical in facilitating adhesion between the dollies and coating. Lab tests have shown that for aluminum dollies and the Araldite adhesive, surfaces prepared with a 3M Scotch-Brite pad demonstrate strong, reliable bonds. Any residue generated by the dolly preparation method should be wiped away with a dry, clean cloth or paper towel. When preparing coating surfaces, the challenge is to prepare a clean surface that will readily bond with the adhesive without changing the properties of the coating. Each coating will vary, as will its preparation method. Preparation may range from wiping with a dry cloth to degreasing with alcohol to gently abrading to promote adhesion. When mixing 2-part epoxies, it is important to follow the manufacturer's directions. Critical instructions include quantity of each part used, homogeneity after mixing, prevention of air bubbles, and staying within the working life. To facilitate the process, kits include all the equipment required for mixing. A single plunger application tube is used to provide equal parts of epoxy and hardener. A uniform coating of adhesive should be added to the surface of the dolly. When placing the dolly on the surface, it is important to push straight down to squeeze out excess adhesive. Twisting, rocking, or sliding of the dolly may generate undesired air bubbles. Excess epoxy should be wiped away from around the dolly without disturbing its position. Dollies to be placed on uneven, vertical, or overhead surfaces should be held in place with removable tape until fully cured. To prevent adhesive failures, it is important to allow the adhesive to cure per manufacturer's instructions. In some instances, the addition of heat may promote stronger and faster bonding. After proper cure time, the operator must decide whether or not to cut the coating around the dolly. As a minimum, any excess epoxy that appears during the curing process should be carefully cut away to prevent an increase in the pull-off area. A common method is the use of a cutting tool with an inside diameter matching the dolly size. When deemed necessary to cut through a coating to relieve unwanted lateral bonding stresses, the method utilized should minimize the induction of surface flaws such as microcracking. Such flaws may lower test results and create fracturing, resulting in partial pull-off results. For testing thick coatings with a 50 mm dolly, an optional drilling template may be preferred to a cutting tool. The final step is the performance of the pull-off test. Ensure the pressure relief valve on the pump is open. Place the actuator assembly over the dolly head. Attach the quick coupler to the dolly by reaching through the holes in the actuator assembly to lift the quick coupler. Release the quick coupling when the dolly head is completely engaged. Close the pressure valve on the pump tightly. Use the one-touch buttons to verify the dolly size to be tested and the measurement units. Press the Start button to initialize the tester for a pull. Prime the pump. The large, easy-to-read LCD display will continuously indicate the pressure in the system. For optimum results, it is recommended to reach the pull-off target pressure in the middle of a stroke. Unless stated differently in the test specification, continue pumping at a maximum rate of 1 MPa, 150 psi, per second until the actuator pulls the dolly from the coating. The graphical pull rate indicator enables the operator to monitor and adjust the rate of pull. After the pull-off occurs, open the pressure relief valve. The display holds the maximum pull-off pressure value. Since calculations are made automatically by the tester, there is no need for conversion charts for different dolly sizes. After completion of a pull-off test, data from the reading, including pull-off pressure, rate of pull, dolly size, and test duration, can be placed into memory by pressing the Save button. When readings have been stored in memory, the Memory Mode icon appears. Stored readings can be reviewed by pushing the Save button or by downloading to a PC for further analysis. Mark the dolly for future qualitative analysis. An ideal pull-off test removes 100% of the coating from the substrate or particular coating layer. Anything less may require both quantitative and qualitative analysis. To conclude, the pull-off adhesion testing process is made up of several critical steps. These include the selection of an appropriate adhesive, preparation of the dollies and coatings, adhering the dolly to the coating, the dolly pull-off process, and the final analysis of test results.